All right, pre-AP chemistry. So this is a video on how to calculate percent composition. And so in your notes, percent composition, it says, is the relative mass that each element contributes to a compound. And so we know that we calculate percents all the time. So percent of the population that is making under X amount of dollars or making over X amount of dollars, that 1%er. We talk about how many, the graphic of, how many 15-year-olds are currently attending North Crowley, how many 16-year-olds, how many 17-year-olds, how many 18-year-olds. We talk about, like, we could do the percentage of teachers that are science teachers, that are math teachers, but we do these percents all the time, and we run these reports of percents all the time. And so we do the same thing, but we do them with chemistry, and they, I think, serve a little bit more purpose in chemistry. That being said, it's just percent, and if you remember from math, percent is just your part over your whole times 100. So for instance, if I had 3 apples and I had 7 bananas, my total is 10, right? 3 plus 7 is 10. So I take 3 apples over 10 times 100, and that gets me 30%. 7 bananas over 10, and then multiply by 100 gets me 70%. 30 plus 70 equals 100, so I know I did my percents correctly. So it's the same concept here, just we're gonna do it with chemicals and chemical formulas. So to be able to do the percent composition of a formula, first you have to solve for the molar mass. And if you solve for the molar mass the way I taught you, then it makes your numbers and life so much easier. So I already did the molar mass for aluminum oxide. So I listed my elements, listed how many, multiplied by the mass found on the periodic table, and then added them all together. So I've done step 1 for us, so that way we didn't have to waste time on the video. But step 1 is to solve for your molar mass. Step 2 is to pick the element. So sometimes a question may ask you, hey, what's the percent by mass of aluminum and aluminum oxide? Or sometimes they say, hey, what's the total percent composition? So we're gonna find the percent composition for both of them. But you're gonna pick your element. So if I want to find the percent composition of aluminum, I'm going to look at aluminum first. I'm going to pick the total mass contributed by aluminum. I'm going to pick this one right here. I'm not picking the molar mass, because if I picked the molar mass, what was the point of solving for the molar mass of the compound? No, I pick the total mass contributed by the compound, or by the element. So I'm going to pick, so for aluminum, I'm doing 53.96. I'm going to divide it by the total molar mass. So 53.96 divided by 101.96, okay? And then I'm going to multiply it by 100. So my part over my whole times 100, and that's gonna give me percent, okay? So I'm gonna go ahead and do that in my calculator. And so whenever I do that, I get 53% roughly, I'm rounding. 53%. Mathematically, I know then I should get this one to be 47%, but we're still going to work it out. So then you're going to do that for the next element. So I'm going to now take 48 for oxygen and divide it by my total, which is 101.96, and times 100 because it's out of a percent. So percent's always out of 100, so we multiply by 100. So then I'm going to do this one too. So I'm going to take 48 divided by 101.96. And I get 47.077, so 47%, okay? You're gonna want to round to decimal places. I just did a rough estimate so you could see. So we're gonna recap how to do percent composition. Step 1, solve for the molar mass. Step 2, take the mass of the element, divide it by the total, okay? Then times 100, and then you're gonna round. You'll repeat it for every element in the compound. If they all add up to 100, then you know you did it correctly. And so 53 plus 47 equals 100. Or if they round up to 99.9, that's also good too, because sometimes there's some error in there. But that's how you do percent composition, so hopefully that's helpful to you.